Now let's take some more examples of function notation. Let's see some equations this time. Example 1. Consider two functions. Fx equals to 2x minus 1 and gx equals to x squared minus 3. Now we'll try to solve some problems. This will help you build better concept. Okay. First problem. Show that f of 2 is greater than g of 2. Yes. Here we have a function f of x defined as 2 times x minus 1 and g of x defined as x squared minus 3. F of 2 means we'll plug in the value 2 here and find the value of f of 2. Similarly, to find g of 2, we'll plug in 2 for x, substitute 2 for x and find g of 2. And then see which one is greater. So let's start. F of 2 equals to 2 times 2 minus 1, which is 4 minus 1, 3. How about g of 2? G of 2 is 2 square minus 3. 2 square is 4. 4 minus 3 is 1. Of course, 3 is greater than 1. Therefore, f of 2 is greater than g of 2. Okay, let's look into some more algebraic operations using functions. Find x for which, you say find x for which f of x minus 1 equals to gx. Now, to solve this problem, we are going to replace x with x minus 1 in function of x and then equate the two equations and find out the value of x for which both are same. So let's do it separately first. Fx minus 1 for this equation is what? Fx minus 1. So we'll replace x with x minus 1. So it's 2 times x minus 1 minus 1. Open the bracket. 2x minus 2 minus 1, which is 2x minus 3. So fx minus 1 is 2x minus 3 and g of x is x squared minus 3. Let's equate them now. So when we equate them, we get to find f of x minus 1 equals to g of x, we'll replace this f of x minus 1 with 2x minus 3. So 2x minus 3 is equal to gx is x squared minus 3. Minus 3. Let's solve this equation. Let's bring these terms to this side and we get 0 equals to x squared minus 2x minus 3 plus 3, which is 3 minus 3 is 0. Here we get x squared minus 2x. We can take x common, x minus 2. Now when will be x times x minus 2 0? Where we can equate this to 0 or this to 0. That means we have two solutions. One, x equals to 0 or x equals to 2. Therefore, we say that f of x minus 1 equals to g of x when x equals to 0, x equals to 2. Now, let's do some more algebraic operations with these two functions. See. This time we'll do function of a function, okay? We'll do f of g of 2. F of g of 2. Now what does this mean? This means that we know gx, what is gx? Gx is equal to x square minus 3. So what is g of 2? G of 2 will be 2 square minus 3, which is 4 minus 3, 1. So we'll replace this value, g of 2, with this, and we'll get what? F of 1. Now to find f of 1, what we will do? We know fx is equals to 2x minus 1. F of 1 will be, replace x with 1. 2 times 1 minus 1, which is 2 minus 1 equals to 1. So that's how we get function of a function. Let me now show you another important thing, which is kind of tricky. Here I will show you a technique to do iteration problems. Sometimes we define a function in terms of other two previous values. For example, let me first write down a function and then I'll explain you. Let's say function f of n is equals to 2 times f of n minus 1 minus 5 times f of n minus 2, where f of 1 is equal to 1, f of 2 is equal to 3. We need to find f of 5. How are we going to do it? Let's first understand. We are given f1 values, f of 2 values, and the function says that to get a function value, the previous two values are required. So with these two values, we can get the value f3. So let's see what is f3 first. F of 3. f3 is equals to 2 times f of 3 minus 1. What is 3 minus 1? f2. Minus 5 times f of 3 minus 2. 3 minus 2 is 1. F of 1. Now here, you know, what is f2? f2 is 3. So we'll replace f of 2 with 3. Minus 5 times f of 1 is what? 1. 1. 3 times 2, 6, minus 5, which is equals to 1. So now we know what f3 is. Let's try to find out what f4 is. f4. Using the same formula, 2 times 4 minus 1. So f of 4 minus 1 is 3. Minus 5 times 4 minus 2, which is f of 2. So f of 4 is 2 times f of 3. F of 3 we calculated 1. Let's put that value. Minus 5 times f of 2 is given to us as 3. So we have 2 times 1, 2, minus 5 times 3, 15, which is equals to minus 13. Now let's find f of 5. F of 5 will be 2 times 5 minus 1, f4, minus 5 times f of 5 minus 2, which is 3. So f of 3. Now 2 times f of 4 is, we just calculated, minus 13. Minus 5 times f of 3, 1. So this is 2 times minus 13 is minus 26, minus 5, which makes it minus 31. So by doing these operations in sequence, we can find the value of f5, and here it is. f5 is minus 31. So that's another interesting way of using functions in function notation. Here is a question for you. You can try this. The function is defined as f of n is equal to 5 times f of n minus 1 minus 3 times f of n minus 2, where f1 is equal to minus 1, f2 equals to minus 2. You need to determine the value of f5. Follow similar procedure and see if you have really understood the concept. Thank you.